Welcome. My name is Gary Tennell. I'm an SMTA ambassador and Dallas chapter president. This is another in a series of Dallas chapter technical webinars. We are going to be covering a wonderful topic today, moving your cleaning process from the lab into production. And Debbie Carboni is a fabulous speaker and high energy spark plug. She's a wonderful person and a close friend. She's part of our SMTA extended family. Allow me to walk through our introduction slide. This is copyrighted, so you are welcome to view the video, but please do not rebroadcast it because it's property of Debbie and SMTA. Okay, I'm going to let everybody read the mission of the SMTA and the value proposition, but basically the SMTA is a wonderful network of professionals that help each other, and it's been around, what, 27, 28 plus years, something like that.
30 plus.
30 plus. Oh my gosh, time flies. So, and it gets better and better every year because of people like Caitlin and Debbie on board over here. So we thank them and everybody else. This is on the Dallas chapter because you're logging in as part of the Dallas chapter webinar, which is an extension from our Dallas chapter meetings, but we do have some individuals log in attending this from other parts of the globe outside of Texas, believe it or not. So Debbie, this is where I'm going to turn it over to you because you are intimately familiar with this as a VP of Expos, to tell us a little bit about this for those few people who don't know about it, but this is your opportunity to share with them to make sure they participate. Go ahead.
Excellent. Well, thank you, Gary. And I want to thank the Dallas chapter. We just love working with the Dallas chapter. Your chapter is always doing a lot of sharing of knowledge and networking with the community, and you've expanded that out, so I appreciate that. Yes, as far as SMTA International, I'm actually pretty excited about this year's. I will tell you that in the past I've attended some virtual expos, and what I've found is they were kind of like visiting a web page and not very interactive or exciting or worth my time, frankly. But this year, the platform that SMTA has selected offers us the ability to have interactive opportunities and engagement on the show floor, as well as during the 3 days, the 28th through the 30th, so that we can keep that community sense and in that sharing of knowledge, plus the friendships that many of us have really joined in and appreciated through the years. So a couple of features that will be shared as well so that you can navigate through the expo. You're going to see different booths. We have over 50 exhibitors now. And we also have a pretty significant number of new time attendees as well, people who have not had the opportunity to visit the expo because of travel restrictions or time away from the manufacturing floor or the office. And so we're seeing people be able to do that. When you go into the booth, you're actually going to be able to enter into a live chat with whoever is manning that booth at a particular time. You can do that during your regular work hours, after hours, when you're bored, when you're having happy hour, when you're having coffee. And if you can't sleep, you can always jump online at 24 hours. Those companies that do have the ability to staff their booths 24/7 are going to be doing that. Some will, some will not. They will also have a significant amount of free information that you can download from there. And you get a chance to win a board or a Peloton bike, as well as potentially an Apple Watch, and I believe it's a Bose speaker. So it's really cool for participating. In there, you can also schedule or ask request for a one-on-one video chat or one-on-one chat so that you don't share information with others. You can also, some of the companies are going to be offering live demos as well. So you can actually see into their manufacturing floor, which is pretty cool, actually. The other thing we want to make sure of is that you don't miss the networking opportunities. So we have the women's networking opportunity, which is not exclusive to just women, although we have lots of us there. We also have we have that going on during the 28th through the 30th. We also have a young professionals and students networking. I believe they're having some trivia, and we actually also have a networking event for those of us who are more veterans of our industry, and I think they call us the Gen Xers and Boomers. So we hope you'll come in, you'll join us through those Zoom meetings, and you'll take advantage of it. The conference itself is each session is actually on demand and going to be available for 30 days. And SMTA has generously offered to do these, offer a group discount should you have 4 or more people from your company. So it's a great opportunity for you to have your employees and your employers support further education on many different levels. The conference is or the expo is free, lots of good details there, and then the conference is very reasonably priced. And it's because of a lot of people like you, so thank you. And I probably took up more time, but I get really excited about this because it is actually interactive, and it's the first time I have actually seen a platform that offers as much as this one does. So.
Debbie, awesome. Very good. I couldn't have said it any better. You are the passion. Well, I know you so well, but everybody else needs to know. Debbie Carboni is involved in the electronic industry for more than 20 years. She actually started when she was 9, and she's 29 now, believe it or not. Yeah. And encompassed a diverse set of experiences to give her a deep knowledge of cleaning chemistry, equipment, and processes. Having been with KYZEN for over 10 years, Debbie is dedicated to providing customers and partners with the highest quality customer support and service, as well as ensuring that they receive the best technical solutions. Her extensive real-world experience helps guide engineers during qualifications to ensure success in the production conditions. Debbie is dedicated to the electronic industries, has included a number of roles and volunteer positions in many of the industry's leading associations, and is currently serving her 2nd term of the SMTA Board of Directors as a Vice President of Expos, and she does a lot more than that too, believe it or not. Attending Northern Arizona University, Debbie remains knowledgeable through numerous technical conferences and leading edge research. Debbie, I'm going to turn it over to you. You're on.
All right, fantastic. Thank you guys for having me today. I love talking about cleaning. Cleaning printed circuit boards, I should say. So I appreciate the opportunity. One thing that I have done through the years is really learned a lot of little details that have made a difference and helped me help others. And a lot of that's been done through the SMTA. So I wanted to take this opportunity to really share some of that knowledge that I've been privileged to participate in learning myself with you, and hopefully with any luck, this will help you solve some problems and avoid some heartaches later down the road. So want to talk a little bit about the influencing factors that lead to process shift. A lot of us live that every day in our daily job, but we don't necessarily understand the full impact, and it's really a critical portion of the cleaning. I also want to talk about material considerations, board handling considerations, best practices, test plans, and process monitoring best practices, and then I want to answer your questions. So as we look into cleaning, we have to recognize that our industry really has evolved over the last few years. And I would say that in the cleaning world, the last couple years have tremendously evolved. I would say that, the evolution of electronic cars or electric vehicles has really become kind of like the BGA was and No Clean was in our industry, where it's really sparked a lot of research. It sparked a lot of opportunities for learning, and it's driven technology to meet new standards. And so a lot of what I'm going to share with you today is driven some from the electric cars, but a lot because we as consumers need to have higher demand products. If you think about how the geography has changed and evolved over the last couple of years, you can see where, we had lots of space, lots of real estate, lots of green. Cleaning was traditionally from vapor degreasing. We moved into then later to saponifiers, materials that lasted very short periods of time. In the 2000s, we started to utilize solvents that were sprayable to handle the no clean debuts. We started moving into pH neutral materials with longer wash time, so compatibility was needed. And then today and even tomorrow, we're having to see a shift in those material sets, primarily driven because we need to have improved rinsing, we need to have better compatibility, we need to have better cleaning. Those standoffs underneath those components are very small, and the amount of green real estate between those components is very narrow. And so being able to understand that all of those different factors from a technology standpoint have really driven critical quality issues with an increase of ECM, electrochemical migration. What we're seeing is more intermittent failures, basically no fault founds occurring pretty frequently too. We're also seeing shorts, and of course you also do see catastrophic failures. When we say that, people say, but it's no clean. And yes, you're right, it is. But the reality is we still clean RMAs and we still clean water solubles. The difference is that our actual, and let me see if I can get these videos to run here. They are. What we've seen is that the spacing between our conductors have really reduced in size, and the materials have also evolved. And it does not take as long for a dendrite to grow between the cathode and the anode. This is actually showing you a video of two different flux materials and how they grow differently. Notice that they're both growing dendrites, but notice that one's growing at a much faster rate than the other. But it also should show you that flux B actually looks like it's going to have a hard failure. And what we also know is that something like flux A, where it's reaching to that other area very quickly, it has the potential to burn out that dendrite and still continue to function, causing that intermittent failure and no fault found. The reality is that the amount of time that a failure can take place, whether it's catastrophic or intermittent, it is very short, and it's all driven by the geometry that we're building today. What we also need to understand is that cleaning is a process. It is putting a printed circuit board into some sort of a machine or manual cleaning. It is washing it, it's rinsing it, and it is drying. It is also maintaining the wash and the rinse processes, making and ensuring that they are staying stable and consistent. And it's also understanding that the board positioning and the handling afterwards leads into that. What you're seeing is product goes in, product goes out, more chemistry goes in, which means, and also to refill up. And while you're refilling that chemistry, you're also taking out some of the wash solution as well. The cleaning process is actually a very dynamic process. A lot of times we just say, okay, well, you're putting that board in and you're spraying it. The reality is, yes, that is the function, and one might even call it, I've even been known to call it a car wash for a printed circuit board. The reality is we're dealing with multiple different types of fluxes. We're also dealing with various different types of mechanical energy, whether it's spray under immersion, whether it's spray in air with coherence or fan jet type nozzles. But we're also dealing with exhaust losses, which can take certain chemistries and pull out some components more than others. And we're also dealing with different chemistries along with whatever mechanical energy we're placing at it. So understanding how all of those different influencing factors plays into it is really critical to establishing a process stability versus your process capability. What we know is that today, the people who are engineering the cleaning machines as well as the cleaning materials, we are very capable of establishing a cleaning at day one. We know how to get a board clean when you're in pristine conditions. We study this day in and day out. What we see is that, you know, when you have all things set, when you don't have third shift, say, working on it, you can create a process window that's wide, and you're going to see your assemblies come in. You have very regimented, very designed, very consistent products that are going through, and you're determining that, yes, this is what I can see, this is what I can clean. And you can even shrink that process window up very short so that you have a very small window. So you're running at the lowest possible conditions, the lowest amount of time, the least amount of chemistry, the lowest amount of temperature, and you may be able to keep that clean. The challenge is that when you introduce that into production, then you introduce variables that aren't always as controlled as what we tend to run in a lab type environment or during a process qualification. And what we call that is a production process window. What we know is that we have to accommodate and design our process window, our upper limits and our lower limits, so that we can adjust when a product comes closer to the upper limits or closer to those lower limits, and we're still able to achieve that cleaning process. Otherwise, without it, we're going to be on that edge, and that's when we're going to see some of those intermittent failures and some of those inconsistencies in reliability as well as cleaning. So when we look at those 5 factors, as I mentioned earlier, cleaning really starts with the soil itself. We also, as a cleaning process, we look at the reflow process, because just like what you do at home when you're cooking, if you turn on your heat a little bit too high, chances are is you're going to burn that rice or that recipe, whatever you're cooking, and you can actually make a very, very difficult to remove residue. But understanding how that heat impacts your cleaning process is really critical and a key part of how you can have success in the future. The other area that we look at very closely is understanding the geometry of what your boards that you typically produce are like. Do you have flip chip devices? Do you have bottom termination components? Or are you just dealing with a standard BGA that's not a big deal at all to clean? Or is it a micro BGA where you really struggle to it? We also look at that overall layout of those to understand those influencing factors. And hopefully by that, we can determine what chemistry is going to give you the best results, understanding that, and then also determine with whatever mechanical action you're hitting it, we can help you establish the right upper and lower limits, at least for a starting point. We take that into that cleaning evaluation, and we realize that the goal of our cleaning evaluation is really to provide clean assemblies at the lowest cost possible. That means the fastest cleaning time, so that you're not spending a lot of time, so that you're able to produce, I should say, more product in a shorter amount of time. That's going to require less concentration, less temperature, and you could probably even go to less energy. The evaluation, as I mentioned, is typically done in a lab environment. That may be at your factory where you have a fresh bath and your machine is either new or it is recently had maintenance done on it, so that your nozzles are all lined properly, nothing's clogged, your pumps are working well, your machine is cleaned out, everything is in pristine order. What we also usually see is that printed circuit boards are collected, and sometimes those are production boards, which is not a bad approach to take. But there's also a lot of times industry boards that are used, and we try to pay attention to upstream builds. You know, are you doing a double reflow? Are you just doing a single? How many passes are you cleaning between each reflow or heat cycle? How does that all play into place? And that is typically what most engineers are looking at when they go into a cleaning evaluation. That is absolutely a great starting point. The challenge is the process shifts over time because we don't live in a lab environment. So we understand that, yes, we can select a board that does have components that are similar to what you're using on your floor, but we don't always necessarily take into consideration that components have different manufacturers. And I have actually seen instances where the cleanability from one supplier to another can change. Is it a major difference? Most of the time not, but can it be? Yes. Understanding that up front is really a key point to understanding how to establish a reliable and robust cleaning process. What we also know is that how you design your stencils can have an impact, especially with QFNs. A couple years back, there was a study that we participated in looking at how we can increase the cleanability underneath QFNs by doing different stencil designs underneath those, whether they were window panes, panels, slashes. There were a variety of different areas. Putting via holes. What we found is that your stencil design and how you create that can actually impact how much flux residue is left behind for us to remove, as well as how easy it is to remove, because it does change that dynamic. It's a small little deal that can make a big difference. The other thing that we try to look at is the complexity of boards. And most of us on the manufacturing floor, when you're building boards, you don't have a whole lot of influence, especially if you're a CM, on the PCB layout, your solder mask, or the stencil silk screen that's on those boards that can actually create a dam. So we need to understand those factors and accommodate for that when you're doing your evaluation. Upstream processes, altering, people, you know, sometimes alter their reflow profiles to fix a soldering problem. Sometimes an operator might decide to not do that cleaning process in between the reflows. Your paste life, there have been some research done into how your paste may alter, and now we actually have jetting paste, and the amount of pressure can influence your process. Understanding that, you know, we can't control everything, but we can build a process that has a wide enough process window to accommodate for those shifts and those changes between, and recognize that rework is part of that, and make sure that you understand how that could impact. From a cleaning machine standpoint, you know, there are a lot of different factors that are also influencers, and I wanted to go through a couple of these in a little bit more detail. You know, definitely people may not realize that the exhaust has a more significant impact. One thing that I think a lot of us are recognizing is flux load. Flux load does have an impact on your cleaning process. And when we clean on day 1, we need to ensure that we're cleaning the same on day 30. And you also have a variety of different other things, such as your DI water quality, the machine maintenance, and let's not forget the third shift and what they may or may not have done. So if we think about the exhaust, it really does influence your chemical losses. It also influences your bath life, the rinse quality, because if you have your exhaust not hooked up correctly, you can actually drag in chemistry into your rinse zone, which can create foaming, which can impact your rinsability, and you could be leaving behind some of your wash solution that has flux in it that you're trying to remove so that you can avoid problems from a reliability standpoint. It can also impact the equipment life and also the operator experience. This is actually a real video I took showing you a customer was having problems. They were foaming in their rinse, so they started shutting down their exhaust, and they dampened it down so that they would hopefully not pull as much over into their rinse. What ended up happening is they were exhausting out from the front end of the machine. Being able to control that is a really key experience. What we know is that your fresh bath does behave differently than when you're at the end of life. The key is that while you have your flux, your tape, your masking, whatever else has been put into there, it does impact that cleaning process. Engineer it so that you understand and work with your suppliers so that you can have uh, a, an estimate of what you're going to be using from exhaust and drag out to impact that soil load. You can get to a point where you always stay below that critical cleaning level from a solubility standpoint. But recognize also that as you load up, you may have to actually increase that concentration in order to achieve the same level of cleanliness. Without it, you're going to be hitting white residue. So you have a choice of either reducing your bath life and dumping your bath more frequently, or increasing your process so that you're not at that edge. What we also know is that it's not just the cleaning that's impacted, but also the rinsing that's impacted. What does that mean? Really, what we're seeing is a combination that happens both in the rinse as well as in the wash, where you have a 10% concentration with fresh chemistry. What we know is that a low surface energy means that you have a dirtier surface, and a high surface energy means that you have a clean surface. What we see is that as you load chemistry or fluxes into your chemistry, that your contact angle and your surface energy changes. And it changes to where you're leaving a little bit more behind. Is it enough to cause a problem? It can be. You need to understand where that is and how that influences it. Things you can do is control your chemistry. Having constant concentration and constant temperature will give you a consistent process. Without it, you're going to see variation in your process because this has a much higher concentration than this or this, and this one could be way out of control. Concentration can also change the compatibility of your process, of your materials that you're cleaning, as well as your cleaning performance. Understand the energy at the board surface as well. Recognize that if you have a clogged nozzle, it's going to change how that water comes out of that spray nozzle, as it does here. It may also, as you can see, these are designed to come down at a 90-degree angle so that you're perpendicular to the conveyor belt. That gives you the best energy in past studies from a cleaning performance. However, if you have not necessarily done your PM and you have that spray bar not only having clogged nozzles, but let's say that it's at an angle and not pointing directly down on it, now you've changed the results of that. And it's not a whole lot different than if you were to just throw your boards into a wash chamber and expect them to become clean. Likewise, if you, like this is here, likewise, if you have your boards too close together as they are here, the likelihood of those coming out at the end of the wash cycle where they're on top of each other is it's pretty great that they would come out like this. And you're not necessarily going to have good cleaning underneath these boards that are on top of each other here. Likewise, if you look at this here, you have these boards that are actually fixtured in this fashion, whereas you have these that are fixtured in a different fashion. The energy and the amount of cleaning, the time it takes to clean these as opposed to these, could be different. Understand those factors so that you build that into your process parameters. Material compatibility. I mentioned earlier that you want to make sure that you have an understanding of what your process parameters are going to have on your materials. You want to have enough energy and temperature and concentration in order to clean and remove the flux residue, but at the same time, you don't want to be causing damage to what's on your boards or your machine itself. What we know is that your time, temperature, and concentration can impact compatibility, both on the board itself as well as the machine itself. Higher temperatures and higher concentrations can lead to more wear and tear on your machine, and they absolutely will lead to a higher cost of the cleaning process as well. The key to your success is going to be to establish your upper and lower limits with all of those things in consideration. By doing that, you will establish a window that accommodates for your process, let's say alterations or process conditions where they have influencing factors. They're not always the same. And by establishing and understanding that, giving yourself enough so that you're not right on that edge will allow you to avoid, allow you to avoid hitting a situation where your process is not stable. Equally as important is handling. Make sure that your operators, once they've spent the time to clean and rinse and dry your boards properly, make sure that they're handling, whether they have gloves on or not, make sure that they are handling the boards correctly so that you're not leaving behind those fingerprints or contamination relocation. If they have gloves and they're handling them on the board, and I've seen it happen even though we tell them not to, you can actually put contamination onto a critical area, which can cause you problems. And there have been documented cases of such. But the good news is that most of us are paying attention to that. What I get concerned about is so often we're so concerned about the cost that we forget about the reliability. And so an operator may not decide to change their gloves as often as they should. And as a result of that, you can actually see here where they sent this particular, I think this was actually a wafer that was sent off for conformal coating, Parylene coating actually, and you could see that they could actually identify the person that touched that particular part improperly. So now that we've talked about what can happen, let's talk about how we can get the work done and do it right. A recommended approach from my view and from many of my colleagues that deal with this day in and day out is work with your suppliers to establish the process parameters. Most of us in the cleaning industry do thousands and thousands of tests to understand what the cleaning relationship is between various different between different fluxes and pastes. And we do that so that we can understand the influence of the temperature that's needed to solubilize that, the amount of concentration that's needed to solubilize it, as well as the best chemistry depending on the type of equipment that you have. That is what we really study in and out. What we also do is recognize that you usually are determining the type of flux that you want because of the upstream processes you're having to handle, whether that's lower voiding or whether you're needing to address some solder, head and pillow, whether it's tombstoning, whether it's stencil life, whatever that might be. You've selected that paste for a process. It's our job to figure out what the best way is to clean it. That gives us an idea of where we're going to be and how we can establish it. The other thing you want to do is to determine a representative evaluation board. If you've got QFNs on your board, you want to have a board that has something that's very similar to that when you're setting up your processes. And again, talk with your suppliers. Dial in that process using visual inspection and with the understanding where that upper limit is and where you see no return on increasing those parameters and no damage on increasing those parameters. And at the same time, understand what happens when you push the envelope and you run at a lower concentration. If your target is at 10%, I would suggest understanding where your cleaning is going to be at 8%, what your compatibility is, as well as what your cleaning is, because that is a critical piece to it just as much. Bump those limits both on the upper end and the lower end to allow for your variation in your production conditions. And then validate that process in the lab type environment with both chemical as well as electrical testing. There's actually work being done on the IPC standard, J standard, to really take that to another level. And they are recommending that you use both the electrical as well as the chemical. And I'm going to share with you a little bit of why here in just a few. The other thing is I really strongly recommend is we spend a lot of time and a lot of energy on validating the process. What we don't always do is spend a lot of time in validating that process when it's in production conditions. And what I mean by that is we often do the SIR and the IC work ahead of time, but then rarely until there's a problem or until you run into issues, do you go back and rerun some of those tests? And what I would recommend is know where those are, where your limit is. Know when that bath's going to die, and understand what happens in your production floor. Periodically run a test board through and visually inspect it if nothing else. So we've actually seen where your cleaning process really, your problem is usually component specific. There are known components, QFNs, bottom termination components. You work with us. If you were to show me your board and say, hey, Deb, you know, I have these kind of assemblies. This is what I'm looking at. Where should I look? Chances are I can point you in the right direction and say, I'd inspect around these areas, or I'd focus on this type of component or that type of component, because we've seen that time and time again. What I would also say is consider the potentially compatible materials that might be problematic. Again, we usually know what those are, and include those in your process. Include the number of cleaning passes in your evaluation, because as you have longer exposure, that's going to pull out the issues that you may run into with your cleaning. Likewise, it could actually improve your cleaning rate, because if you're evaluating just on one pass, that may not be representative of what you run today. So it's important to understand that, and include your possible high and low limits to really understand where your risk is associated. Today, we have several different types of test methods that we can use to determine flux residues, ionic contamination, leakage currents, dendritic growth, corrosion, as well as material compatibility. The key is really that all of these methods, or most of these methods, will give you a quantitative number. However, without objective evidence and really understanding what that number means, it's not going to buy you a lot. So again, work towards understanding that. Options that you have to start with is component shearing, removing those components, whether using a die and pry device or desoldering. Recognize that desoldering can actually cause more residue to come out from entrapped voids. Another tool that has recently been introduced is ceramic glass slides. These have chip caps on them that are very closely connected, and they're really designed to fail in most cases. What we see though is it helps you dial in that process and understand how much time, how much concentration, and how much temperature do you need in order to get the best results. And that can help you in at a very low cost to you. The IC, you have methods of doing a full board submersion, which is most common, dam and fill, which is pretty time consuming and also not necessarily as repeatable. There is localized IC testing, and of course the C3 testing. It does give you that objective evidence. The challenge is that while we have industry established limits for each one of those, that does not mean that you're necessarily going to have a clean enough board. It does give you some data so that when you're troubleshooting, you can refer back to it. And I do believe that that is a really important process. Very rarely, though, is IC used for monitoring. The challenge is that without that electrical testing, really you can, the ionic contaminations do not determine if you have a failure. Localized testing is absolutely going to give you better insight into where your potential risk is. However, you can get false negatives, and there are limitations underneath with solubilizing some of the components. Products have passed the C3 but failed environmental testing. And what is often not understood is that when you're dealing with a bottom termination component, you may not be able to pull out from a localized test with that C3 underneath the MOSFET or a QFN or an LGA without mechanically removing those and testing both the bottom side of the component as well as the bottom side of your board. So it's really important to understand that. Whereas SIR testing really does give you what's going to happen when you put that board, that assembly, under stress. Most commonly, we use the B52 board for this. We run the IC, which gives us that fingerprint net analysis of what's in it. And then the SIR gives us an electrical value and gives us an indication of what happens when we put the board under stress, under harsh conditions. By adding the humidity and the voltage over a period of time, you can understand what's happening to your process, both on upper and lower. Today, we now have custom test boards that are available. And these test boards actually not only measure from just a daisy chain, so to speak, with your SIR boards, but they're actually putting traces underneath these components. So you can actually see what's happening underneath between those leads in real time. That gives you a lot better consistency and can give you the assurance that your risk is very limited, or to know where that risk is. And you can use that to establish your process at a much lower cost than what you would with a traditional B52 type board with standard SIR and IC testing. The other thing that you want to do is rerun those qualification tests in some form, whether that's every 4 weeks, 6 weeks, 8 weeks, 12 weeks, every 100 hours, 200 hours, 500 hours, after every X number of boards. This should be done by no less than visual inspection, but preferably quantitatively with SIR or IC. And I say that because that gives you the objective evidence that's going to validate and really ensure that you don't have risk. That takes into consideration the process variations that production produces with and also the effect that soil loading has on both your wash as well as your rinse. Monitor that bath life so that you understand what is happening to it. Not only just the concentration, but also your alkalinity ratio, which tells you how much cleaning capacity your chemistry has to a certain degree. Also your soil load. Benchmark that. You can actually determine when you need to change that bath out based on this. And also the rinsability. I have seen where numerous companies struggle with rinsability, especially in connector type devices, where they see that change, that surface. So it's not as easy to rinse that product out as it loads up with that soil. So doing a simple rinsability test by measuring it with virgin being at 72 dynes, and as you see to start to lower below those 60 dynes, or whatever the number is that you determine is problematic, then you can change it out and you have some solid evidence to do that. Control and monitor that process in production is really the key. If you do the work and you have both the IC as well as the SIR data at the qualification, you can then validate that in production conditions or at any particular time, and you can eliminate the amount of time it takes to troubleshoot issues. So I wanted to take a couple minutes, and hopefully I'm not going too long, to share with you a case study. And I will provide this information in PDF format for you as well, so that you can go through it at your leisure and at a slower speed. There was a military customer, and they wanted to ensure that they were having a process that was in control. So they had moved from one chemistry to another chemistry, and then they wanted to validate their process in production conditions. And what they had experienced in the past was actually having to increase concentration in order to keep consistency over the life of that bath. But they also wanted to make sure that they had no issues with compatibility and reduce the amount of concentration. So they lowered that concentration. They have an AquaStorm machine, and they use B52s originally. What we did was use an SIR coupon to revalidate this process through as well, and use that data to go and compare to qualification. What we found is that we were able to move from a higher pH material to a next generation material, which did have better compatibility, lower pH, and more environmentally friendly. They moved from a 13 to 15% down to a 10 to 13% concentration, and they also kept their temperature at 140 degrees. And they wanted to keep their wash cycle at about 2.5 feet per minute. I actually was very surprised personally about the 2.5 feet per minute, but that was okay. They previously were seeing a bath life of about 4 to 5 weeks, which equated to about 85 to 90 hours. What we were able to do is establish more than 6 weeks of bath life. That was their goal. And they were cleaning a wide range of materials. Visual inspection, you can see here before wash, after wash, you see the flux residue completely removed from a visual. They also wanted to make sure that they had no negative impact on their part markings or their labels. And so they also said that, you know, they typically run 2, sometimes 3 passes through their inline. So they ran a test with 3 passes on their problematic parts with no effect. Their SIR results during qualification, very good. What we did was monitor their bath and looked at this during over the life of it. They started to see a little bit of a change in some rinsing, as well as white residues. And so they actually said at about 12 weeks, they had a 312 hours of pump run time. Their NVR was at 3.7, and the rinsability had gone down. After 12 weeks, you can actually see this is the impact SIR gives to you. You can see how those numbers did start to come down. You could also see where these are dipping. What this is probably showing us is they were starting to grow those dendrites. If you remember the videos earlier, they probably burned through them, but process is still acceptable, but it's on that edge. So what we recommended they do is go ahead and bump up and reduce the amount of time. So they reduce the hours and are changing out their bath at 300 hours. They were able to do that by using those B52s, and they were able to improve their process. They extended their bath life. They were able to reduce the consumption that they had from the chemistry costs, and it didn't cost them any more on energy. So with that, I want to open this up to questions. Yes.
What do you see in the last year? What's the one advancement that you've seen in the cleaning business in the last year that probably will be seen at SMTA International Online?
So that's a great question, Gary. I actually see that there's been more focus and a lot more drive on rinsing. So from both a material standpoint as well as a mechanical standpoint, I think you're going to see some additional research being introduced there. I also believe that the other big change is how we determine clean. You know, for the last 5 years, there's been a big, huge focus on how clean is clean enough. The reality is that everyone's how clean is different than another's. So determining how to do that effectively is where I think the industry is going. IPC is really pushing towards that as well.
Yeah, looks like one came in. So Debbie, as we move forward, will there be more cost-effective electro and electromechanical testing for cleanliness?
Yes, there are. Actually, I am aware of a couple. One, in full disclosure, our sister company has been working on that for a couple of years, Magnalytics. But in addition to that, I know that there are several other companies, and the industry really has a push for having some of these devices. I think the C3 was one of the first ones that really helped establish the best, you know, the best on-site, low-cost cleanliness testing method.
Great. Also, there looks like a question on networking opportunities. I think between Gary and probably Debbie, knowing that you're a part of the SMTA network, what does that look like, I guess, now that we're all virtual?
Well, okay. Well, let me carry the first one, the obvious one, and I'll let Debbie come back with the follow-up on that. Networking, the whole association is all about networking and helping each other, sharing the knowledge. So the best opportunity is through the chapter meetings that unfortunately nobody has right now. But the next vision is just what we're doing, you know, right now. The other thing is by SMTA International Online. I mean, that's going to be a virtual network.
I would also say that a couple of different things. One is SMTA chapters in general are opening up their meetings virtually to have other people come in. One of the other things that's happening is the water cooler hours, and I believe that Karen establishes those once a month. I participated on the last one. I have to say it was a lot of fun. I'm looking forward to the networking for us Gen Xers and baby boomers during SMTA, where we're going to have some games and socialize and share some of our favorite stories. And then I know companies are actually starting to encourage that as well. You know, it's definitely a new world. I haven't been on an airplane in 8 months. And I used to be on one at least once a week, if not multiple times. So that's we're constantly looking for some of those networking opportunities, and us at the board level and at the headquarters levels, we're definitely looking for those as well.
That's great. Yeah. Next question here, more related to the cleaning. Will the new IPC cleanliness controls have a positive effect for the industry from your perspective?
I do believe it will give more definition. I think that this, where the IPC is going, they're giving a lot more answers. They still haven't said, you know, this is a pass go, but what they are doing is saying, hey, listen, the Rose test, it's great for making sure that you're rinsing your product really, you know, well and consistently. It's not necessarily going to identify if you have a problem. They are saying that IC is great, but it has its limitations. I think that's a positive. I think knowledge is powerful, and it's going to have a positive for us. I also think it's going to help OEMs understand some of the challenges that assembly houses are facing from that aspect.
Awesome. Next question here. Can you describe how passives on glass slides are used for process assessment?
Absolutely. So great question. So I'm going to show my age now. I actually used some glass slides with a customer probably 18 years ago, and they had actually put together their own fixture design. And what they were trying to do was really understand, you know, they would feed the inject the flux underneath the glass slide, and they had certain diameters, and they wanted to be able to ensure that they could clean underneath that process. I actually think with those glass slides, what you can actually do is run that through your bath periodically, whether it's, and everybody talks in by days or weeks. I prefer to actually talk more in number of assemblies or number of hours, pump run hours or cycles. And I say that because really flux load is what is influencing it. And if your pump's running, you're going to be increasing the flux load. That changes your process. I can't tell you how many times I've talked to a customer where they were saying, oh, I want to run at 10%. I'm like, you're right on that edge. I'd run at 12 so that you're never reaching below that. What you can actually see though with those glass slides is be able to see that as it goes through at 100 hours, you're still seeing the same level of cleanliness, the same amount of flux residue. Those glass slides actually are also sold with a like an AOI type system where it gives you a digital readout. You could make your own. You could do it, you know, just visually percentage of whatever flux is left over. As long as you have consistency in that process, you're pretty assured that your overall cleaning is consistent too. So it's very cost effective from that aspect. I can send you additional information should you want to receive more. But basically, you're just running it through. You go through a process. You inject the flux that you're using underneath the component. You heat that up. You run it through the reflow process, and then you run it through your cleaner.
Sure. Next one here. What is the best fixture for washing a single PCB inline?
Oh, I love this question. Can I tell you I hate baskets? So actually, I am a big proponent of less material on the bottom side or the top side so that you prevent shadowing. You can, I have a series of different fixtures, pictures of fixtures that I've collected through the years. You engineers are really creative and you come up with some great ideas. But the more you can do to limit the amount of screening that you put on your boards, at least use a 1/2 inch. Avoid your stamped materials. That's going to save you chemical costs hugely. But most importantly, it's going to save you a ton in cleaning rework, because when you use those patterns and when you have tight meshed, you're not going to get that impingement energy. You're really getting a diffusion on that board surface. It's all about what happens when the board and where the energy meets the board and penetrates underneath the component. You need that energy at the highest amount in order to get the best cleaning.
Last question here we have so far. Since there is renewed interest in space hardware, does IPC have higher qualification criteria for this hardware or plans for it?
That is a great question. I am not sure on that end of it. I know that a lot of the IPC cleanliness standards have our industry gurus from the space industry, and they follow the class 3. They are definitely class 3 specification customers or assemblers. What I would say and what I will share is I have heard rumor that the automotive industry is looking at establishing their own cleanliness specifications, and I think that other industries will follow. If you think about it, whether it's space, whether it's medical, or now automotive, those are critical areas and people are paying attention, and I do believe that that's what's really driven the changes we've seen on the cleanliness specifications, that changes that we're seeing. We just came out with Rev G, and I know that the next Rev is being reviewed at the moment.
Great. Awesome. One last and final question, I think. What ionic species is most dangerous to long-time reliability?
Oh my goodness, that is pick one. It's the one that actually happens to be on your board and cause it. You have your usual suspects, which is your chlorides, your bromides, your fluorides. But in all honesty, you can have contamination come from anything. If it's in the right spot at the wrong time and you have moisture, you have potential risk. And the challenge is that it's not that it will always happen, but it will happen if it's put into the right environment. Understanding what those are, and that's why we do the chemical analysis as well as the SIR, I think is valuable. And I personally put a lot more merit in SIR testing. When I saw what was happening underneath with the SIRs underneath those QFN devices, light bulbs went off. It is really, really, it didn't matter whether it was a chloride, it didn't matter whether it was halide free or halide containing, they both were failing. And that's very evident. It's not one particular species that's worse than the other. Granted, there are some materials that are, that are less problematic than others, but definitely makes a difference.
Gotcha.
Wonderful answer. Debbie, thank you very, very much for your presentation today, for your Q&A. Caitlin, thank you very much for hosting us and keeping on track and making sure everything runs so smoothly. You both do a wonderful job. Thank you to Glenn and James on the Dallas Chapter Technical Committee for their inputs and participation in setting up this event. We are very excited about what's coming up, and we very much look forward to seeing both of you and all of the other SMTA family members at SMTA International online in just a couple short weeks.
Absolutely. I hope to see you there. Come stop in, say hi. I will be at all of the networking events if I can. So please join us and bring your stories. Love to hear.
Very good. Thank you very much, and goodbye all.
All right, thanks.